Hi guys, so let's talk about the centripetal acceleration circular motion questions on your test review. So if we take a look here, this question down here, why is circular motion also called centripetal acceleration? Use the diagram below if you need to. Okay, so let's look at my answer first, and then we'll go back and we'll break it down. Because circular motion is the type of motion that creates centripetal acceleration. So let's think about what we know about the word acceleration. So acceleration is a change in velocity over time. Okay, now remember velocity, oops, that's really sloppy. Change in, you can't even see it. Change in velocity over time. So remember velocity, this is speed, the number, and a direction. Now, I could be going at the exact same speed the entire time. Maybe I'm going 100 meters per second, okay? That speed could stay precisely the same for hours and hours and hours and hours. But what is going to change when I am traveling in a circle is the direction that the object is going, okay? And I'll show you that in just a second with the picture. So because it's change in velocity over time, okay, I don't know where I was going with that thought. The number of velocity isn't always changing. I already said that, but the direction of the movement is. That's what the VO, VI, and V2 lines, not lions, coming off of the circle represent. Okay, so I'm really hoping that the graph didn't disappear on you guys like it did for me. So let me get out of here. This needs to go away. All right, so here we go. Let's take a look at this. Let me zoom, maybe. Come on, computer, here we go. Okay, so if I am standing here in the middle of this circle, right here at the center, I don't even know what that's called in a circle, the center point, and I have this, let's think of the water, okay? If I am the person holding the contraption that we did outside where it's in, or you're in the middle and you're holding on to it. This is the rotation point. So this isn't necessarily the center point here, isn't necessarily my body. It's the center of that circle. So where my fingers were hanging on to that hook as it spun around, okay? This point right here, these dotted lines, this is going to represent the arms, I guess, of that contraption, of that swing. It could be rope like it was with the people in the video. It was the plastic part as I was spinning it. And right here along the edge where this little square is, and right here, this would be the cup of water as it goes. Okay? Now, these right here, this is showing me the direction that object is wanting to travel. Objects are going to travel in a straight line unless something forces them to change. So if I have a cup right here and I were to let go of it right at that point in time, that cup is not going to fly straight up. That cup is going to want to fly this direction because just a split second before it, I was over here. So a straight line from this point right here is here. It is a perpendicular. It is a perpendicular or a 90-degree angle. Okay, so as it goes from, here's my string attached to the cup wants to keep going this way. Okay, as I'm spinning that, there is a force pushing down onto the cup, which is what's keeping the water in the glass. Now, the trick of this is you have to go fast enough in order to keep the water in. Okay, you could make one of those own things at your house. There is a trick though. If you design your own, let me go back here. If you design your own thing, okay, so let's do a side view, okay? So if I have my tray and I have my cup of water on here, or anything, okay, and I have 2 or 3 or 4 strings, this and this string have to be exactly even. There cannot be, so this one, if it's 36.5 and this one is 36.25 inches, if this happens, this will not work because you will have a lopsided thing and it's going to fall off. They have to be exactly precise and exactly even in order to make this, okay? So let's do a top-down view. So if I'm looking down, here's my cub. Considering if you're doing a rectangle, you would have to have 4 entry points, and those entry points also would have to be exactly evenly spaced. So like you couldn't have what I've drawn here. So I couldn't have this circle hanging out here a little bit further inward compared to this one, okay? So I hope that helps with centripetal acceleration. If not, let me know and I'll see what I can put together for you guys, or what we can do to talk about it. But I think that about covers all of it from our test review. So awesome. Great job, guys.